Hi, and welcome to another SWAT Pup Gaming video. Today we are talking about the 10 best rules to approach your C++ code. Let's not mess around and jump straight into it. Number 1. Understand the basics thoroughly. Before you sprint into the coding world, aiming to conquer massive projects, it's essential to crawl before you walk, to understand the basics thoroughly. Picture yourself as a builder. You wouldn't start constructing a skyscraper without mastering the art of laying bricks, right? It's the same with coding. Your bricks are the fundamental elements. Variables, functions, arrays, vectors, structs, and classes are all building blocks of your software architecture. Knowing what a loop does, how an if statement alters your code's path, or why a pointer can be both powerful and dangerous, sets you on a path of mastery. You can build a skyscraper out of bricks and mortar, but if you don't know how to hold the trowel, you will never get to the first floor. So, before you leap into crafting intricate algorithms or designing sophisticated systems, make these fundamental concepts your allies. Number 2, embrace the core principles of object-oriented programming. Imagine stepping into a world where everything you build not only has a foundation, but also character and identity. This is the essence of diving into the core principles of object-oriented programming, or OOP. In this world, classes are not just classrooms where learning happens. They are blueprints from which every building, every structure, every entity springs to life. Think of a class as a recipe. Just as a recipe can be used to bake countless cakes, a class is used to create numerous objects, each with its unique properties and behaviors. Objects, then, are the living, breathing instances of these blueprints. If our class is a blueprint for a house, each object is a house built from that blueprint, distinct in its color, design, or the furniture it holds. But a structure is more than just its blueprint. It inherits traits from its surroundings, its predecessors. This is where inheritance shines, allowing new creations to stand on the shoulders of giants. A skyscraper might inherit the sturdiness of its foundation from a long lineage of architectural wisdom. Then there's the art of polymorphism, the ability to take on many forms. A single function, like draw, could sketch out the outline of a circle, a square, or a triangle, depending on which shape it's applied to. It's the magic of versatility, allowing us to interact with objects in a way that they understand without knowing exactly what they are. Lastly, encapsulation is the act of keeping what's private. Just as you wouldn't expose the wiring and plumbing of your house to the world, encapsulation hides the inner workings of our objects, revealing only what's necessary through windows and doors, or in programming terms, public interfaces. Embrace these principles, and you'll start seeing your code not just as lines and loops, but as a vibrant ecosystem, each part interacting harmoniously with the others. It's not just about building software, it's about crafting a world where every element has a purpose, a relationship, and a story. Don't be afraid to embrace OOP. They can be scary when you start out, but are essential when you continue your journey into the future. Number 3, master memory management. Imagine memory as the uncharted territories of space, vast and full of potential. As the architect, it's your job to allocate plots of this space for your creations, whether they're simple data structures or complex objects. But with great power comes great responsibility. Every byte you allocate must one day be freed, ensuring that no part of this cosmic space is wasted or left to turn into a black hole of memory leaks. Oh yes, we are talking about dynamic memory allocation. This is your toolkit for crafting stars and planets in the void. Using commands like new and delete in C++, you control the life cycle of your creations, breathing life into them and deciding when their time has come to an end. It's a dance of creation and destruction, performed with the precision of a ballet dancer on the stage of your computer's RAM. But beware the pitfalls of memory mismanagement, the dreaded memory leaks, where forgotten data lingers like ghosts in the machine, and dangling pointers, which point to realms of memory long since reclaimed. These specters can cause your programs to stumble, leak precious resources, or crash into the abyss of segmentation faults. Smart pointers come to the rescue, wielding the power of modern C++ to automate much of this cosmic ballet. Like trusty droids, they manage the life cycle of dynamic memory for you, ensuring that every allocated byte is eventually freed, no ghostly data left haunting your program. Mastering memory management is like learning to navigate the cosmic currents. It empowers you to build efficient, robust, and reliable software. It's a journey of understanding how to respect the resources at your disposal, use them wisely, and always ensure harmony in the vast cosmos of your code. Number 4, utilize the standard template library. The standard template library, STL, is an essential toolkit for every C++ programmer. Think of it as a set of building blocks that can significantly speed up your development process. At its core, the STL provides three main components: containers, algorithms, and iterators. Containers are like versatile storage boxes. Whether you need an array that can dynamically resize itself, a fast access map for key value pairs, or a list where you can efficiently insert and remove elements, STL containers have you covered. Algorithms are the tools for processing your data. Need to sort a list, find a specific item, or shuffle elements? There's no need to write these from scratch. The STL offers algorithms ready to be applied directly to your containers, saving you time and effort. Iterators are the glue between containers and algorithms. They allow you to traverse through a container and access or modify its elements. Think of iterators as universal pointers that work across all STL containers, making them incredibly flexible. Utilizing the STL means writing less code while achieving greater functionality and performance. It encourages code reuse and helps maintain consistency across your projects. By mastering STL, you're not just coding efficiently, you're leveraging a collection of tried and tested tools that can elevate your C++ programming to the next level. Remember, embracing the STL is about making your coding journey smoother and your programs more robust. It's a practical step towards becoming a proficient C++ programmer. Number 5. Follow best practices for error handling. Handling errors in your C++ code is like being a goalkeeper in soccer. You need to be prepared for the unexpected and keep the game going smoothly, no matter what comes your way. Here's how you can do just that with some savvy error handling techniques. First up, exceptions are your best friend. They're special responses to special situations, like when your code is asked to divide by 0. Think of exceptions as the referee blowing the whistle, signaling that it's time to handle things differently. Remember to throw by, value, and catch by reference. This is like passing the ball accurately. It ensures that your error messages don't lose any crucial details when they're passed around your program. Use the standard exceptions that C++ provides. It's like sticking to the rules of the game. These standard exceptions are familiar to other programmers, making your code easier to understand and manage. Adopt the RAI strategy. Resource acquisition is initialization. This principle is about making sure your program cleans up after itself, automatically releasing resources like memory or file handles, even when an error occurs. It's like a good defense strategy in soccer, preventing the other team from taking advantage of any openings. Write exception-safe code. Ensure your program can stand firm and not crash, even when faced with errors. It's the equivalent of having a solid defense line that doesn't buckle under pressure. Finally, document your exception handling clearly. Just as a coach outlines strategies before a game, documenting how your code handles errors makes it easier for others to understand and work with your code. By following these best practices, you're not just avoiding errors. You're making your code more reliable, robust, and ready to tackle whatever challenges come its way. Number 6, write clean, maintainable code. Writing clean, maintainable code in C++ is like organizing your workspace. It not only makes your life easier, but also helps anyone who might work with you to understand what you're doing quickly. Here's how you can keep your code as neat as a pin and as clear as daylight. First, name things clearly. Just like labeling everything on your desk, use names that describe what variables, functions, and classes do. If a variable counts the number of apples, call it numapples instead of something cryptic like NA. It's all about making it obvious at a glance what each part of your code is for. Stick to a style. Whether it's how you indent your code, where you place braces, or how you name things, consistency is key. It's like following a filing system. It doesn't matter what system you use, as long as you and everyone else can find what they need when they need it. Keep functions focused. Each function should do one thing and do it well, just like how a drawer in your desk might be dedicated to stationery only. If you find a function is growing too large or handling multiple tasks, consider breaking it into smaller, more manageable pieces. Use comments wisely. Comments are like sticky notes on your monitor. They should remind you why you did something, not how you did it. Your code should be self-explanatory for the how part. Reserve comments for the why, or to explain complex logic that isn't immediately obvious. Refactor regularly. Keeping your code clean is an ongoing process, not a one-off task. Just like regular desk tidy-ups, refactoring your code by simplifying complex sections, removing redundancy, and improving efficiency can keep your project healthy and maintainable. Embrace code reviews. Just as you might ask a colleague to check over a report, having another set of eyes on your code can help catch issues you've missed and ensure it's as clean and clear as possible. It's also a great way to learn from each other and maintain a high standard of code quality. Writing clean, maintainable code is an investment in your project's future and your sanity. It's about making your code so clear and well organized that anyone, including future you, can quickly understand and modify it without getting tangled in a mess. Just like a well-organized workspace, it makes coding more enjoyable and less of a chore. Number 7. Implement effective debugging strategies. Implementing effective debugging strategies in C++ is like being a detective on the trail of a mystery. It's about using the right tools, adopting a methodical approach, and having the patience to follow the clues to their source. Know your tools. Just like a detective has a kit, familiarize yourself with debugging tools available for C++. From simple print statements to sophisticated debuggers like GDB or Visual Studio Debugger, knowing what tools are at your disposal and how to use them effectively is the first step in tracking down bugs. Isolate the problem. When you encounter a bug, try to isolate it. This means creating the smallest possible scenario in which the bug occurs. It's like narrowing down your list of suspects in a mystery novel to just a few key characters. Understand the flow. Use breakpoints to pause your program at strategic points and inspect the state of variables. It's akin to setting traps to catch the culprit in the act. Stepping through your code line by line can also help you understand exactly where things go off track. Check the usual suspects. In C++, certain bugs occur more frequently than others, such as memory leaks, pointer errors, or off-by-one errors and loops. Keep an eye out for these common issues. Often the problem is something you've encountered before. Use version control to your advantage. If a bug has suddenly appeared, use your version control system to compare the current code with earlier versions that were bug-free. It's like looking at what changed in the scene of the crime that could have led to the current situation. Ask for help. Sometimes you need a fresh pair of eyes. Don't hesitate to ask a colleague to look over your code. Explaining the problem to someone else can also help you see it in a new light, a strategy known as rubber duck debugging. Document and learn from every bug. Each bug is an opportunity to learn. Once you've solved a problem, take a moment to document what caused it, how it was diagnosed, and what the solution was. This not only helps prevent future issues, but also turns each debugging session into a learning experience. Becoming proficient in debugging is not just about fixing problems. It's about understanding why they occurred in the first place and preventing them from happening again. With patience, persistence, and the right approach, you can tackle any bug that comes your way. Number 8. Practice writing secure code. Practicing writing secure code in C++ is like fortifying a castle. Just as a stronghold must be defended against all possible points of attack, your code must be robust against threats that could compromise its integrity, confidentiality, or availability. Understand common vulnerabilities. Begin by familiarizing yourself with the types of vulnerabilities that commonly affect C++ applications, such as buffer overflows, use after free errors, and SQL injections. Knowing your enemy is the first step in defense. Validate all inputs. Treat every piece of data entering your program as potential contraband. Rigorously validate inputs for type, length, format, and range. It's like scrutinizing every visitor at the castle gate to ensure they pose no threat. Use safe library functions. The C++ standard library and other modern C++ libraries offer safer alternatives to the functions known to be risky, like those that don't check bounds. Opt for these whenever possible. Think of it as choosing tested and proven defenses over outdated ones. Practice the principle of least privilege. Just as not everyone in a castle needs keys to the armory, your code should not grant more access rights or permissions to its components than absolutely necessary. This minimizes the impact if a component is compromised. Sanitize data used in SQL queries, URLs, and other outputs. Ensure that any data output to databases, web pages, or other systems is properly sanitized to prevent injection attacks. It's like making sure messages sent from the castle are coded to prevent information from falling into the wrong hands. Implement proper error handling. Avoid leaking information through error messages that could help an attacker. Craft error messages that provide necessary feedback without revealing details about the codebase or database. It's the informational equivalent of not letting siege engines know whether their shots are hitting critical targets. Keep up with security updates and patches. Regularly update your compiler, libraries, and other tools to their most secure versions. This is like keeping your castle's defenses up to date with the latest in moat design and arrow technology. Educate yourself and your team. Security is a constantly evolving field. Stay informed about the latest security research, vulnerabilities, and best practices. Encourage a culture of security within your team, where everyone is aware of the risks and committed to protecting your code. Writing secure code is a continuous process of learning, vigilance, and adaptation. By incorporating these practices into your development routine, you can ensure that your C++ applications are not only powerful and efficient, but also safe and secure fortresses in the digital landscape. Number 9. Keep up with modern C++ features. Keeping up with modern C++ features is like continually sharpening your tools in a craftsman's workshop. Just as a skilled artisan doesn't rely on dull blades or outdated methods, a proficient C++ programmer takes advantage of the latest advancements in the language to write more efficient, readable, and robust code. Here's how you can stay sharp and up to date. Embrace the latest C++ standards. C++ is a living language with major updates released every few years. Each version brings new features and improvements, such as smart pointers and simplified range-based for loops in C++11, standard optional in C++17, and concepts in C++20. Familiarize yourself with these enhancements. They're designed to make your life easier and your code better. Use auto for type inference. The auto keyword, introduced in C++11 and expanded in later versions, allows the compiler to deduce the type of a variable. This not only makes your code cleaner and easier to read, but also reduces the likelihood of type mismatches. Leverage smart pointers for memory management. Smart pointers, such as the unique pointer, shared pointer, manage dynamic memory automatically, helping prevent memory leaks and dangling pointers. They're essential tools in modern C++ for writing safe and efficient code. Explore the power of lambda expressions. Introduced in C++11, lambda expressions allow you to write inline anonymous functions. This can greatly simplify your code, especially when using algorithms that require custom functions. Utilize the standard library. The C++ standard library is continually evolving, with new algorithms, containers, and utility functions added in each standard revision. These tools are highly optimized and tested, providing reliable solutions that can save you time and effort. Stay informed through the community and resources. Follow C++ conferences such as CPPCon, join forums like Stack Overflow and the C++ subreddit, and read blogs by prominent C++ experts. The community is vibrant and always willing to share knowledge. Practice with modern features. Theory is one thing, but practice cements knowledge. Try out new features in small projects or refactor existing code to utilize modern constructs. This hands-on experience is invaluable. Be mindful of compatibility. While it's tempting to use the latest features, remember to consider the compatibility with your project's target platforms and compilers. Sometimes pragmatism leads to choosing more widely supported features over the newest innovations. Adapting to the latest C++ features not only makes your code more efficient and expressive, but also keeps your skills sharp and relevant. As the language evolves, so too should your mastery of it, ensuring that your craftsmanship remains at the cutting edge of software development. So far, we have looked at 9 of the 10 best rules to approach your C++ code. And before we take on number 10, if you enjoyed this video, please like and subscribe to stay tuned to more videos like this. All right, are you ready for number 10? Here it is. Number 10, engage with the C++ community. Engaging with the C++ community is like joining a guild of craftsmen, where everyone from the novice apprentice to the master artisan gathers to share knowledge, solve problems, and push the boundaries of what's possible with C++. Participate in online forums and Q&A sites. Platforms like Stack Overflow, Reddit, and the C++ community on Discord are bustling with activity. Whether you're seeking advice, offering solutions, or simply reading through discussions, these forums are invaluable for staying engaged with the latest in C++ development. Attend conferences and meetups. CPPCon, Meeting C++, and local C++ user groups offer fantastic opportunities to learn from leading experts, discover emerging trends, and network with other professionals. Presenting your own work can also be a great way to contribute and gain visibility. Contribute to open source projects. There's no shortage of open source C++ projects looking for contributors. Whether you're fixing bugs, adding features, or improving documentation, contributing to projects not only benefits the wider community, but also sharpens your own skills. Stay updated with C++ standards. The evolution of C++ is an ongoing process, guided by the work of the ISO C++ Standards Committee. Following their publications, proposals, and debates can give you insight into the future direction of the language. Learn from blogs and podcasts. Many C++ veterans share their insights through blogs and podcasts. These can be gold mines of information, offering deep dives into specific topics, best practices, and innovative techniques. Engage in code reviews. Participating in code reviews, even informally, can be a powerful learning tool. Reviewing others' code provides new perspectives and challenges your understanding, while having your own code reviewed can offer constructive feedback for improvement. And remember, by commenting on this video, you're already taking a step to engage with the community. Every comment is a chance to start a discussion, share your perspective, or ask a question. Interaction fuels the community, building a space where everyone can learn and grow. Engaging with the C++ community isn't just about improving your own skills. It's about contributing to a culture of knowledge sharing and innovation. Together, we can tackle complex challenges, inspire new developers, and advance the state of software development. So don't hesitate to dive in. The community is waiting. All right, that was our list of the 10 best rules to approach your C++ code. See you next time.